My name is Dylan Darby, and today we're going to be presenting the car sales database along with my presentation partners, Caleb, Trey, and Brandon.
Hi, my name is Brandon Fisher. I am with Group 12, and I will be talking about the business summary for the car sales database. The car sales database is designed to serve both vehicle buyers and brand ambassadors at dealerships by centralizing essential sales data into a single accessible system. So, the car sales database is designed to support two main user groups: consumers that are shopping for vehicles, and brand ambassadors or sales professionals that are working at the dealerships selling the vehicles. Purchasing a car is a significant investment, and consumers often face frustration navigating multiple platforms to find reliable information. Similarly, dealership professionals rely on data to analyze performance and refine their strategies. So there are two main problems nowadays with buying and selling vehicles. Buyers often face information overload, where they bounce between forums, websites, and reviews just to compare a few models that they're not sure if they're interested in. Similarly, sales professionals want performance data but have no centralized tool for analyzing trends or success factors. So, our database simplifies this process by storing key information such as model year, fuel type, transmission, body style, color, and historical US sales figures. By pulling data from trusted sources like goodcarbadcar.com, the system reveals key factors that drive vehicle sales and provide users with actionable insights. Whether you're a consumer comparing base model options or a sales professional evaluating trends, the car sales database enables smarter, faster, and more confident decisions. So just to recap on our solution for the problems previously discussed about not having a centralized place to look at car information, our database centralizes and organizes trusted data from sources like goodcarbadcar.com, which is one of the most reliable and trusted car review sites in the nation, by using attributes such as vehicle make, model, year, body style, etc.
Today I'm going to be discussing our business rules. These are the business rules we enforced while designing the database. Rules 1 through 3 ensure all vehicles are new, sold in the US, and in base condition. Rules 4 and 5 make sure the vehicles are from 2015 or newer and priced under $200,000. Rules 6 through 8 define relationships. Each vehicle has only one engine, one drivetrain, and one transmission. And we also require that each vehicle has both an interior and exterior color. Rules 9 through 11 continue defining how our vehicle data should be structured. Each vehicle must be assigned exactly one body style type, may have multiple optional features, and must have a single aggregated rating record. These rules keep the data clean, consistent, and easier to query across different categories.
Hi, my name is Caleb Abear, and I'll be going over our team's entity relationship diagram, some sample data, and how we avoided repetition in our data, as well as some queries for our database dealing with database triggers. So taking a look at our ERD, as you can see, we have a central vehicle table with several related tables surrounding it. The design that we went for is that each row in our database will correspond to a unique configuration of each vehicle in the database. So for example, a Honda Civic sedan would be a unique database entry separate from a Honda Civic hatchback. And furthermore, two Honda Civic hatchbacks with different engine configurations or something would each have their own entry in the database. And that holds true for any vehicle configuration. And these tables, as you can see, they mostly have one-to-many or one-to-one relationships with the vehicle table. That is except for the feature table, which actually has a many-to-many relationship, but uses the vehicle feature table as an intermediary. And when it comes to normalization, our database does meet the criteria for both first and second normal form. For example, all of our entries are atomic. We have a unique primary key for each row in each table. We have no partial dependencies, etc. We did realize towards the end of the project that we didn't quite achieve third normal form, And the main requirement of third normal form is to have no transitive dependencies, which is to say that columns can't depend on anything but the primary key. And unfortunately, we do have one transitive dependency, and that is the model column in the vehicle table, as you can see. And that depends on a non-primary key make. So with our current configuration, you could technically insert a Honda Camry or some other invalid make and model combination in the database itself. There's nothing preventing you from doing that. And to correct this, we would just need to add another table to store the models, similar to how we handle the other lookup tables like engine, interior color, things like that. So moving over to some sample data and avoiding repetition. So here we have our sample data, and this is querying the vehicle table and joining on the rating table. So we primarily avoided repetition through the use of foreign keys to these additional lookup tables, as you can see. And next up, we will take a look at some sample queries.
So, for our first query, I decided to make it about the top 5 best-selling vehicles in our database. This query is grouped by make, model, and year. It uses a join between the vehicle and sales table, then aggregates the sales with sum, and then sorts by sales volume in descending order. Why this might matter in the real world is for dealerships specifically, it helps identify which models are most in demand so they can stock efficiently and promote the highest performing vehicles. For consumers, seeing the top seller adds trust and simplifies the decision making process for the buyers. Also, buyers often associate sales success with reliability and satisfaction. For our second query, I chose to make a query that returns all vehicles that have a safety rating higher than the average across the entire database. It's grouped by make, model, and safety rating. It joins the vehicle table with the rating table, then filters using a subquery that calculates the average safety rating. Why this might matter in the real world. For consumers, especially families or safety conscious buyers, this helps them quickly identify safer options that might interest them. For dealerships, it can be used to promote top safety picks and appeal to these cautious buyers. It's also useful in collaborating with insurance companies if they might want to do promotions based off of vehicles with higher safety ratings.
For query 3, this query returns the total number of vehicles based on a specific combination of drivetrain and engine type. We joined the vehicle table with the drivetrain and engine tables, grouped by drivetrain and engine, and then used the count function to calculate the total vehicles in each combination. For example, you can see that there are 5 vehicles with a forward drivetrain and a 2.0-liter inline 4 turbo engine. Query 4 lists unique vehicle names combining make and model and shows the year each was sold, sorted from the earliest to the latest. We used concat to combine make and model into one full name, then joined with the sales table to pull in the year sold. This helps us understand which vehicle models were sold and when, which could be useful for analyzing trends over time.
My name is Charamutis, and I'll be going over my first query. So this query showed a list of vehicle models based on how much they cost in descending order. I did this by using the model, then setting the max price as the vehicle price from the vehicle table, grouping by the model, and ordering it by the vehicle price in descending order. So I wrote this query because for a real world example, say that I was a customer and I had a budget of around $31,000. And so when using this query, I would be able to see um, different uh, vehicle models based on the price. So if I had, but like I said, budget 31,000, I would see, okay, the Outback and back and the Prius fall in that range, which then I could go into detail of the Outback and the Prius to see which one would better suit me from what I want. This would be good because instead of having of deep diving into a certain vehicle and then realizing, oh, this is um, out of my budget, um, I can just quickly see that that's out of my budget, and so I don't have to go into details, which I will spend less time actually uh, doing research, and I can just get to what fits my needs. Now, for my second query, I wrote a query that showed a unique list of vehicle make and models as the full name along with their interior and exterior color combinations. I just did this by using a concat of the vehicle make and model to set as their full name, using exterior color name, interior color name variable as well, using the vehicle from vehicle V. Then I joined the exterior color variable with the exterior color ID, and then joining the interior color variable with the interior color ID. So a real world example of this would be, say I wanted a black car. Okay, so then I could look like, okay, so the BMW 330i has a black exterior, the Mercedes-Benz C-Class, the Mazda CX-V, the Land Range Rover shows black as well. And then from there, I'd be like, okay, if I want black, now I want a black interior. So then that'll limit out my options to just the BMW 30i and the Mercedes-Benz C-Class, which then I would be able to choose between those two, depending on my budget and other factors. But this is a great way to kind of find what you want. As customers, we are pretty picky on what we want and how things look. So this would be a great way to kind of decide that factor and really tailor what we want.
Number 7, I'm not sure what order it'll appear in, but this is the first one for me. And both of these will deal with database triggers. And it looks pretty long, but it's actually very straightforward. This one just performs a delete on the vehicle feature table whenever a vehicle is deleted. So as you can see here, it's deleting the vehicle ID where the vehicle ID equals old.vehicle ID out of the vehicle feature table. And the use case for this would be to ensure that we don't have any orphaned feature records that no longer have a vehicle associated with them. So for example, if a vehicle is deleted, you wouldn't want to have a bunch of features that only correspond to that vehicle or that vehicle ID once the vehicle is no longer there. So this would delete those records, and it would perform really similarly to like a cascade delete. All right, so next up. So this query is, or this trigger, I guess, is similar. It deals with an insert rather than delete. And so what it does is it inserts default values into the rating table when a new vehicle is inserted. So this could be beneficial to prevent newly inserted vehicles from skewing the ratings. For example, if the default were 0, it might drop the ratings of one branded vehicle quite a bit if you inserted a few new records. So this could be useful for preventing that.
Okay, moving on to the reflections. As a group, we came together and kind of just went over our projects, what went well, what didn't went well, and kind of just brought up a few points. So the first point I brought up was that when reviewing our files, we realized when completing the SQL file that there was an error in our code, specifically in how the features in the vehicle features table were populating. For the features, we had set it to take in 2 parameters, but in reality, we actually wrote it to take in 3, which was causing the features table to come up as null, which then caused the vehicle features table to populate as null as well. And like Caleb had mentioned before, we could have improved our database normalization to 3NF by adding a lookup table. So Caleb touched on this a little bit earlier when going over the ERD, but basically in our database, we have it just sorting directly into the vehicle table, but we could have used a lookup table to make our database and our ERD look a little bit more cleaner and have that full 3NF for normalization. And Brandon had mentioned the point that even though our group members' schedules didn't line up, we were still able to meet with each other and get the project done. This was one of our biggest challenges, just because we had such busy lives between school, homework, extracurriculars, or work. So we really didn't find the time to meet, or when someone was available, someone else wasn't available. But basically, what we did was that we used Discord as our main communication, to send files and to write down any meeting notes, or to ping someone to make sure they got the message and were able to get all their work done on time and everything turned in. Um, this was either through also meetings, whether that be in the middle of the week or on the weekend. Even if it was just two of us, we would still meet and kind of talk about the assignment and start working on it, and then fill in those who couldn't meet. And then Dylan, he had brought up that we had to slightly change our data that we were collecting, and but we were able to keep our business rules. Basically, in our project draft proposal, we had said that we were going to include the horsepower in our database. But as we moved into the project, we realized that wouldn't be feasible, or not really necessary at all. So we ended up scrapping the idea and only taking in um, a couple of variables that we saw necessary. But on the bright side, we would keep all our business rules and we were able to follow them to the T without any problems at all. Thank you for listening to our presentation, and this was Group 12 with the car sales database.